Okay, everybody, this is chapter 7, section 3, and we're going to deal with similar triangles. In similar triangles, we kind of get back to what we did in chapter 4 and 5 when we dealt with, if you guys remember back that far, angle, side angle, 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 side, side angle, side, 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 side. These are we're going to have a couple that are kind of like that. We're going to be dealing with being able to prove that triangles are congruent by something along those lines of triangle congruencies, okay? So if we look at this first example, remember what we know about triangles too, that all triangles equal 180 degrees. So if you add up all the angles, the sum should be 180, okay? Remember what this symbol is. We did this last section. That means the word similar. So you can look at these two triangles. They're not equal, but we're going to try to somehow prove that they're similar, okay? In this case, they're telling us that. So that's another thing we got to really remember. If they're telling us that, then we can start thinking, you know, the angles should be all equal in the similar polygon. And then the sides, the corresponding sides should all be proportional, okay? So we're going to look at that. Let's find the missing angles. So one, they're telling us that they're similar. If angle E is 90, and if you look here, E and B are in the same position, so that means they're corresponding. So that tells me that B has to be 90, okay? And then if you're looking at that, if they give me that angle F is 51, well, remember F and C should be 51. So you could go about it that way, or you could add up all the angles and subtract it from 180 and get the missing angles, whichever way you want to do that, okay? Now, if all the angles are congruent, I can go down to this postulate, and this is a postulate, it's angle, angle, okay? Now you got to remember, if two angles in a triangle are congruent, then the third one has to be. We kind of learned that a while ago too. And if you remember back when we did triangle congruencies, that means everything was equal. Angles are equal, sides are equal. And now we're saying, okay, the angles are equal, but the sides don't need to be the same. So you got, in this case, I told you way back when that you can't have a theorem that was angle, 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 because you can have a triangle that looks like this, and a triangle that looks like this, and all the angles could be equal, but are all the sides equal? And the answer back then was no. But now, if all the angles are equal, I can say that these two triangles are similar. Okay, so all I need is two angles that are equal in a triangle, equal to corresponding angles in a second triangle. And that way they can be equal, okay? So they give you kind of this drawing here. Here's two similar triangles. They show that these angles are equal. Well, that means that angle T and angle P have to be equal because they still both have to equal 180. So those angles are equal. So kind of the shortcut way is just I need two angles, and I get angle, angle, okay? So there's a similarity postulate using two angles are congruent. That way I can determine that the two triangles are similar, okay? All right, so looking at this, we've got, if we look at A first, this kind of goes back transversal way. You know, if these two angles right here are 90, then that means that these two sides are going to be parallel. So we're coming back to stuff that we learned a while ago, okay? And if they're parallel, I've got really in this picture, I've got two different triangles. So and I'm going to go a long way here and explain this because you could see this type of problem in different ways. So I'm going to take a long way here. First off, you got this big triangle, correct? But then that big triangle at the tip, you have a smaller triangle. Okay, and what we're trying to determine is the big and the small triangle similar. Okay, and we just learned stuff about angles, so I'm going to think it's going that way. But remember, if you got parallel lines here, and they're parallel because both those angles were 90, then this angle here, I'll call it X, and this angle down here, they have to be congruent by corresponding angles. So you've got that transversal thing going on there. So I can prove the two triangles are congruent by, or not congruent, I'm sorry, by being similar, because I got two angles in the smaller triangle are congruent to two triangles in the bigger one. So that's how I get angle, okay? Everybody good there? Now a second way, using the same picture, this is why I'm trying to do different ones here for you. I've got these two angles that are 90, and I've got two different triangles. Well, you look at angle W up here. That angle W is the same angle for the small triangle and for the bigger triangle. So W is really reflexive to itself. Okay, so you're going to get this reflexive property thing occasionally when you're dealing with, especially in triangles. Okay, so there's different ways I can prove angle here. Okay, and the triangles are similar because I've got multiple ways to see that there's two angles that are congruent in each triangle. Okay, and so let me erase this mess so we can see it. Okay. So what I have to say now, these triangles are similar. So I'm going to go triangle, I'll go with the small one first, WVX, similar to triangle WZY. Okay, so once I prove them by something, right now with this the only thing I got to use to prove it, then I can say that they're similar, and I have to write out this similarity statement that I wrote out. You have to be able to write that out. Okay. Now, in the second one, B, they didn't give me any letters or anything, so I'm not going to be able to write a similarity statement, but can I prove that they're similar? Okay. So the hint here is parallel lines. Remember, you see parallel lines, you can think transversal. So I'll go here first. These two are parallel to each other. So that means that this angle and this angle have to be equal. Okay. Secondly, this line and this line are parallel. So that means that these two angles have to be equal because they're corresponding. So now, are my two triangles congruent or similar? And they are, because I've got two angles here and two angles here that are corresponding and they're equal. So they are also equal by angle. I just can't write a statement because there's no letters. Okay. And remember too, this isn't really part of what the question was, but remember too that if those two angles at the bottom of each triangle are congruent, that means these guys up here have to be equal to each other too, because they all have to equal 180. Okay, so this one especially is a test question. I'm going to bet you're going to see this one again. Make sure you're doing that. This is going to be a test question too, and this will be done in many different ways. So this might be you have to set up a proportion to find a missing side. There's a lot of different things we can do with questions like that. But the big thing too is using reflection, like I said up here. That one angle at the tip is part of both triangles. So remember, that makes it a little bit easier for you. Okay. All right. Okay, on this question here, we're going to set up a proportion. Whenever you see something like that, you got a variable sitting out here somewhere. That's just telling me to set up a proportion. Okay. So once again, different ways to set this up, how you look at it, how you feel comfortable with it. But I go corresponding sides. And if you guys notice, I've got hypotenuses here. So obviously those are corresponding to each other. So why don't I just start with that? I'll kind of start on the left and go right. So those two are the hypotenuses are corresponding. I put corresponding sides over each other. That's the way I do it. You don't have to do that. But I got to make sure I set it up the same way in the other ratio. So if I started with 20 on top, I've got to take the other side that's in the same triangle, put it on top, and I put it over its corresponding side, which was 6. Okay, and then I can do the math here. So I'll let you guys do the math real quick, and we'll see what we get here. And remember, I start with the variables, so I'll go 15 times x is 15x, 6 times 20 is 120. Okay, and dividing that. Okay, and I get x is 8. Okay. So that's the way, you know, I set that one up. There's obviously, we talked about this before, there's different ways I could set it up. I could have these two guys switched. I could have both fractions flipped, but you've got to have some kind of making sure that you've got corresponding things set up in the proper places in your fractions to do this right. So you've got to be a little bit careful, but there is a couple different ways to set it up differently and still get the same answer. Okay. Other kids too, they'll ask me, can I reduce that before I do my cross products? And you can. Just make sure that you've got to set it up properly first before you start doing that. Okay. Because if you don't have it set up right at the beginning, then you're not going to get it right. Okay. So typically, I don't always reduce stuff. I just multiply it out. You guys got calculators now. Obviously, reducing it makes it easier, but you don't have to. Okay. All right, for this one, we just got to be a little bit careful here, okay? Because they're giving me more information I really need, so I got to make sure I got, you know, corresponding sides here. One thing that kind of helps me, if they give me these two angles that are both the same, so I got to assume that these are corresponding sides, okay? And then, so that helps me figure out that I can use this. So this one's too much information for me, okay? And I can go set up my proportion. Once again, you can set it up many different ways. I'm going to start with the 35. Its corresponding side is this 25 on the other triangle equals, and since I started with this triangle here, then I'm going to put this side on top, like this one was the 35, and I'm going to put that over its corresponding side, which is x. So that's the way I set it up. Like I said many times before, I'll probably say it lots of times again. There's different ways to set it up. One way is I can switch these two guys here, or I could have this whole thing flipped, or I could even have these guys flip this way too. So just make sure that you got corresponding things going with each other, okay? I'll let you guys do the math on that one. Let's see what we get. I think you get a decimal on this, so just double check that you did it right. Okay, so you got something around 32.1. I think I rounded that to the nearest 10, okay? And typically, they didn't do that here, I don't think. Yeah, they did. Typically, we're going to round to nearest 10th unless we're told differently, okay? All right. Okay. So then we got two other triangle similarities. These should be familiar to you: side angle, side, 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 side. Okay. So remember, and let me start with side, side, side. It's just saying if you've got measurements for all three sides, the proportions of all three sides need to be the same. We did that in the previous section. So you're going to have to prove it that way. Just go all the way around, corresponding side over corresponding side, reduce the fraction if you get, if it's reducible, and then just see if that works all the way around the triangle, okay? The first one, side angle side. So if you remember, the side and the two sides kind of make up the angle, and the angle is going to be equal to another angle in the other triangle. And the sides have to be proportional too, so they have to have the same ratio. Okay, so we're going to really have to, I would really come back and look at these two guys, these two theorems again, and study these. Make sure you got this. You should remember them, but now you got a little bit more work. When they're equal, you can just say, hey, they're equal. That's cool. But now I got to look at the ratios being equal. Okay. Okay. So here, they don't give us any really instructions here, so maybe we could write this down. Determine which of the following triangles are similar. Okay, I'm not sure why this is missing, but got to know what we're doing. Okay. So what I'm going to do is, and to kind of explain this, I'm going to see if this first one, I'll number these two. I'm going to see if the first one and the second one are proportional. Then I'm going to see if the first and the third one are proportional. And then I'm going to see if the second and third one are proportional. Okay. And that's kind of a long way. There's some common sense here thing I'll talk about later, but I just want to make sure you see how am I supposed to handle this problem. Okay, now you got to be kind of careful here too, because if you look at number one and number two, they're kind of flipped. Okay, so what I'm going to do is I'm going to use the biggest side in this first one and the biggest side in the second one and write a ratio. Reduce it if I can. So I'm going to go 4 goes into both the top and the bottom. I get 3/2. Okay. So that means all of the other ratios have to be the same. Just so I know what I'm doing here, I'm going to take the smallest length, which was 6, and the smallest length over here. Remember, I'm going left to right. So I'm putting the one on the left on top, the one on the right on the bottom. 6/4, is it reducible? 2 goes into both the top and the bottom. I get 3/2. So I'm looking pretty good. And now I'm going to take the middle sides and set those up. So 9/6. And I'm going to go is that reducible? And 3 goes into both the top and the bottom. And so I got the same ratio for all three sides, corresponding sides, so that means it is similar. Okay, so I can write a statement that triangle ABC is similar to triangle, and I got to be careful here. I'm going to go FDE. I think I did that right. Triangle FDE. Okay. All right. So like I said, then I'm going to go from triangle 1 and 3 and see if they're proportional. I'm going to kind of use the same thought process. I'm going to take the biggest side. It looks like they're kind of drawn similar too. So the biggest side was 12. I'm going left to right again. Biggest side's 14. Okay. I can reduce that. 2 goes into both the top and the bottom. I get 6/7. Okay. I'm going to take the smallest side here and smallest side here, just values there, okay? And it's 6/6, and that does reduce, but it reduces to 1, and these two ratios are not the same, okay? So they have to be the same to be similar. So I'm going to stop. There's no way I can finagle this to work, so those two are not similar, okay? no solution. They are not similar, okay? So I'm done. I don't need to keep going, all right? Then I'm going to go to the last one. And, you know, these are drawn a little bit differently. So what I'm going to do is kind of make it easy on myself. I'm going to take the longest side, 8. I'm going to go the longest side over here is 14. That's reducible. 2 goes into both the top and the bottom. I get 4 over 7. Okay. I'm going to take the smallest side from this guy and the smallest side from this guy. I'm going to get 4 over 6, and that is reducible. 2 goes into top and bottom, and I get a ratio of 2 to 3. But then I go look, and these two ratios are not the same. So therefore, they are not similar, okay? Now, there's a lot of smart guys and ladies out there. If one triangle is not similar to, is similar to another one, but not to a third one, then that second one is not going to be similar to the third one either, okay? Hopefully that's kind of a common sense thing, but just want to make sure we prove that it's not, and hopefully understood the process there, okay? All right. They're asking, are these triangles similar and why? If they are similar, then we have to write a similarity statement, okay? So we can prove it, they're similar by 3 things. So I'll just write them down. So this is what I'm trying to prove it by, one of these 3 things. Then if I can, then I can write a congruency statement, okay? So here we go. One thing, if you notice, you have 2 triangles. You got a big one, and you got the small at the top. So I'm thinking that angle S is going to be equal to angle S. So that's kind of a reflexive thing. So that's a good thing. So that it might be this, or it could be this. Okay, I'm going to think I can't do it by this. All right. I'm going to go ahead and look at this side of the triangle is 4. And this side of the triangle is 16. So I'm going to make a ratio out of that. And then this triangle here, the side's 5. And the side of this triangle is 20. And I want to see if those are, you can do this 2 ways. You can reduce or do cross products. Okay. If I reduce it, I get 1 over 4 over here. And if I reduce this one, I also get 1 over 4. So that means that the 2 sides have the same proportion. If you did cross products, I'd get 80 equals 80. So that's another way you can prove they're equal, okay? So the sides here are similar. They have the same ratio. And the angle up here is equal to itself. So this one's going to be congruent by side, angle, side. And then I need to write a similarity statement. So triangle, I'll go to the top one. SPQ, similar to triangle SRT. Okay, so there you go. So hopefully you kind of got the thought process there and you're ready to go, okay? So I'm going to let you guys go ahead and do the second one here and see if you can prove it being similar by one of these 3 theorems. And tell me if they are. If you can prove it, then you have to write me the similarity statement. Okay. So I'll let you guys think on that for a second. If you want to hit pause, you can, and come on back, and I'll have the solution for you. Okay, so I'm going to start here with the common sense. All triangles equal 180 when I add off all the angles. So I add the 2 that I got here, and I'm going to go ahead and subtract it. from 180, and I'm going to get, what do I get here? I get 67. Okay. I got 139 when I added those two together, so I'm going to take 180 and subtract it, and I get 41. So 41. So by doing that, now I've noticed that all three angles are equal, and I only technically needed two. So I could have stopped right here because that, or I could have stopped right here, sorry, because I had those two over here already. I just, doing a little bit of work because you could attack it any way you want. So they are similar by angle, okay? So triangle ABC is similar to triangle. I start with A, so I'm going AFDE. Okay. All right, so that's, taking some other rules that you learned from quite a while ago now and kind of applying it to help you get to a theorem that tells you if they're going to be similar or if you prove that they're not similar, okay? Okay, so that takes us to the end of section 3. Please make sure you go back and study those similarities. Really important that you got those down. They should be kind of familiar, but you use them kind of a different way too. All right. If you have any questions, get a hold of me, and we'll get it figured out.